In this presentation, we're going to learn about analysis of variance, or Anova. And essentially, Anova is a statistical method where it compares the means of 3 or more factors. So compared to the parity test that only compared 2 different things, this compares 3 or more. So in this case, you can see I've got data for a monocrystalline solar cell, a polycrystalline solar cell, and a thin film solar cell. So these are 3 different factors, we would call them, in ANOVA. Factor 1 being where our factors are essentially just the different types of solar cells. And what we want to do is we want to see if there is a major mean difference between the different populations. And Anova does it essentially by using the sample variances. And what it does is it goes in and using those sample variances, it conducts it calculates an F statistic, which tells us whether or not the means are equal, or essentially whether or not there's a difference. And the reason why we do an ANOVA versus, let's say, a bunch of different parity tests between the different factors is because it actually helps us limit the amount of type 1 error. So if we did a parity test, let's say between mono and poly, and then mono and thin film, and then poly and thin film, we actually would increase our type 1 error. Now in Minitab, we're actually going to go in and just have Minitab calculate this for us. We're not going to learn how to calculate the F statistic or based off of our sample variances because at this level, really all you need to know is what ANOVA is and how to quickly compute it. And so we're going to show you that in Minitab. So in Minitab, using our 3 different factors for energy that was measured for 6 different days, to conduct an analysis of variance, you go up to Stat, ANOVA. We're going to do a one-way unstacked, and as you can see, I've already put in our 3 different responses, but let me show you. So first is our mono, our second is our poly, and our third is our thin film, and then we hit OK. And what you see is an output, and our output first tells us what our degrees of freedom are, and then the sum of squares, which is associated with the variance, and then this F statistic that I was telling you about that it calculates, and then the last thing it does is give us our p-value. And in this case, our p-value is actually relatively small, so we probably can reject the null, which essentially means that our means between the 3 different factors, so between mono, poly, and thin film, we're basically saying that they're equal. So the other thing it does, if I scroll down, you can see a little bit better, is that it gives us, or it displays the 95th percentile confidence interval for our samples, or for our populations. And recall that 95% basically means an alpha of 0.01. And you can see that the confidence interval for 1 doesn't really overlap with the confidence interval for the third one. So the mono doesn't seem to overlap with the third one. So that's basically saying that there's a high likelihood that the mean for process 1, or material 1, the mono, is different than the mean for the thin film. So this kind of gives us a little bit better view of if there is a difference, where that difference could possibly be. So I hope you have a better understanding of what ANOVA is. Thanks.